All right, hey students. Today we're going to be covering transformations, Unit 1, and especially into intro transformation, which is 1.1. All right, so this is transformations, Unit 1, and oops, a little high there on that line, sorry. And we are covering 1.1, Intro to Transformations, which is basically like your vocab, your terminology, things that you're going to need to know so you understand the problems when they're worded to you. So one thing you should think about is what are some, that is are, by the way, sorry, what are some of the terms you remember about transformations? Okay, well, some examples would be reflections, rotations, dilations, translations, and compositions. All right, there are some other options and other things out there that you can think of possibly, but those are just the basics that we're going to be talking about. Now, in terms of from here, we're going to get into the basics of the definitions. Okay, and I also apologize for this on graph paper. Unfortunately, I was out of normal lined paper, so got to do with what you got. All right. So the first definition we're going to look at is geometric transformation. Okay. And what that basically means, and what the definition of that is, a process that results in a change of a geometric figure's size, shape, or position. Okay? There are 4 types of transformations. That we classify under geometrics. Okay, those are, number 1, translations. Okay, number 2, rotations. Number 3, reflections. Number 4, dilations, which we mentioned previously up above with our question right here. Okay? So what that basically means is that those are the 4 that we're going to be looking at in this unit, or sorry, in this unit and throughout the sections. Specifically, each one will have their kind of own section. We'll be covering translations today, and specifically in the second part of this video. But for all intents and purposes, each and every one of these will have their own video that you guys will see throughout this week, either in class or on here on the videos that I have uploaded to YouTube. All right. So another vocab term you need to know is something called preimage. Okay, and a preimage basically means the position of the shape before the change, being translation, rotation, reflection, or dilation, any of the 4, is made. Okay, And likewise, if we have one for pre-image, we must have one for post. Well, the thing is, we're mathematicians. We're lazy. We don't say post-image. We just say image. It's a lot easier just to say the pre-image first and then just say image after the fact. Okay? And when we say image, what we're referring to here is the position of the shape after the change is made. Okay? And by the way, I am using red here. That just comes out orange on the camera. There's nothing I can do about that. I'm sorry. So hopefully that isn't annoying. Yeah, so that's basically before we change and after we change. All right? Next up, we have rigid motion. Hopefully the echo isn't too bad in the microphone. This room's acoustics are honestly really bad, but there's nothing I can do about that. You'll find in my other videos that those were recorded when I was teaching, and they were in a brick room, and they were much more better. But nothing you can do about that. Next up is rigid motion. Okay. Any way of moving all the points in the plane, and when I refer to plane, I'm talking about the coordinate plane, such that two things remain true. A, the relative distance between points stays the same. That's same down there. Sorry, let me write that. Same. There we go. Same. And B, the relative position of points. Sorry, not points. So the relative position. Yeah, no, I was right. The relative position of points stays the same. Okay. There are 4 examples of rigid motion. Okay. We will state that here. There are 4 types of rigid motion. First one being now 3 of these we've already talked about above up here. Okay, those 3 are translations, two, rotations, 3, reflections, and 4, glide reflections. Okay, so for example, a glide reflection would be if you took a circle, if you reflected the circle in a mirror, it would still be a circle. If you slid the circle over to the second quadrant, it's still a reflection as well. This is the only one really that has a kind of a double entendre, if you will. Okay, so there's the first portion of that. Now I'm going to flip the back side. I apologize that I did this kind of backwards, so this is why this is over here. Sorry. But on this side, now we're going to fill in this little boxes, I should say. Sorry. Okay. Now there are 4 segments to this box. First one being definition. Description is in the next one. Okay. Bottom left one is algebraically. Algebracially. Okay, algebraically. Mouthful of a word. Explain what that means in a little bit. And the last one is graphically. I almost said geographically. Graphically. I can barely English. There we go. Okay, graphically. Great. Fantastic. Okay. So, definitions. Firstly, there are three key aspects to definitions when it comes to translations. And again, this is the first one, and the first one we're going to talk about in section 1.1. Only this one, don't worry. Firstly, is a change in position. Okay. The next thing we talk about is no change in orientation. And the last thing we talk about is the figures are this symbol right here, the little squiggly with the little equal sign underneath it is called, this is congruent. And when figures are congruent, they are what we call isometric. If you don't know what that word means, look it up, okay? A little bit of a challenge there. So pause the video, look that word up right now if you need to. Okay, I'm assuming you're back after pausing it. Okay, but take that word out, read it. If you need to write the definition, I would, but it's a very handy word because basically this means that things are the same measure and are the same design. So again, you'll get a better definition from there. So definitely take that word out. Now, something you need to note about this. Okay, so I'm going to do a dash division here for this box. And this is important. Okay. Following. If you connect the points of the preimage to the image, okay, the lines should be congruent and parallel, 2 backslashes in a row. Again, I would make a note of this down here so you know. Congruent equals this little squiggle with equal sign, and it's just a fancy ampersand symbol. And parallel means 2 backslashes. Okay, so there's the first square done. One other thing I want to mention is that the quote-unquote kind of like slang term for this would be slide, right? You think slide to the left, slide to the right. That's basically translations. Okay, line dances are translations. All right, next up, description. Description is relatively straightforward, okay? When we do translations, we either add or subtract values from X and Y coordinates. Okay? So, for X, hopefully the screen shows up on here. Okay, close enough. Okay, so for X's, right is to add, and left is to subtract. Okay? Hopefully that is somewhat visible. I apologize. I can't zoom in on when I'm recording with this thing. All right. Y's, on the other hand, okay, up is to add, and down is to subtract. Now, we classify the X values as the horizontal component, and we classify the Y's as the vertical component. Now, if you can't read that, good news is I have a PDF of this whole entire thing uploaded under this day's Schoology file. So if you're in Schoology and you go to the next tab, or if you want to check in the description below, for those of you watching YouTube, I might add in there. But if you go to the next link, basically in Schoology, you'll notice that there is a notes completed thing. Click on that, and you're good to go. All right, moving right along to algebraically. So, the original, X and Y, little arrow. Okay, so algebraically just refers to essentially equations, if you will. Basically, things of that nature. Nothing too crazy and chaotic there. So we basically want to write equations. We have to do them in terms of algebra, which basically means you're using numbers and letters. Okay, now for this one, the notation will be x plus or minus a number. We use the pound symbol here. And we'll use y plus or minus a number, a pound symbol, or a hashtag, or the number sign, as I would like to call it. Okay? And then from there, I'll have to go to the next line, sorry. Okay? So this is the rule. And the result, or to get, x prime, y prime. Okay? Pretty straightforward. All right. And finally, let's say we want an example of this. We'll have x, y. Okay? And we want to write a rule for, let's say, to the left 2 and up 1. So it'd be x minus 2, y plus 1. Okay? And finally, graphically. So graphically is pretty straightforward. You've got a pre-image. Whoops, stuck my fingers there. And you have an image. Okay? You got z prime, lowercase t, lowercase b. You got 3 to the 4th. 1, 2, and 4, 0. For our image, we have z prime, t prime, and b prime. We have 1, 5, negative 1, 3, and 2, 1. Okay? So if we graph that, okay, there we go. And I'm going to shortchange myself here if I don't draw all the way up there. There we go. So let's go ahead and graph the first shape, which is basically, let's see, z is at 3, 4, 1, 2, 3, 4. Sorry, my bad. 1, 2, 3, 1, 2, 3, 4. So right here, that's z. T is at 1 and then 1, 2. That's t. And b is at 4, 0. So 1, 2, 3, 4. Right there's b. And now let's just connect our dots. You might want to use a ruler for this, a very helpful little tool. Also, before we started this, if you need to draw the little chart thing that we're using here, make sure you pause the video. I should have mentioned that back there on pause. Sorry, but I didn't make it before starting this video. Okay? Now, you got that. Let's talk about graphing the image. So after our translation, so we've got 1, 5 for z. So we're going to go over 1, 1, 2, 3, 4, 5. So he's up here right below that coordinate value. Sorry, a little tight in here. Z prime. And then let's see, we're going to go back 1, up 3, 1, 2, 3 for t prime. And b is 1, 2, up 1 right here. Okay, let's connect our dots. Okay. And now let's connect the dots. Now, the nice thing about doing this on graph paper, I will say, is that even though the stuff is very transparent and bleedy, like, bleeding ink, what it does have is that it allows us to see that slope, that parallel line effect, and you'll see that every single one of these guys has the same rise and the same run, right? Well, because I'm doing run over run and then rise, but you see what's going on here? Over 2, up 1, over 2, up 1, over 2, up 1. So you can see that it's happening across the board. It's a uniform transformation. All the lines are parallel. All of them have the same slope. Therefore, they're congruent. Therefore, this translation is actually a translation. Okay. And finally, just for an added bonus, the rule. Okay, I'll let you pause the video here and see if you can guess it first. Okay. The rule is left 2 and up 1. So look at that, a little over 20 minutes. Perfect. All right, guys, hopefully you found this helpful. Remember to make sure you have this in your notes. Make sure you do your homework, and I'll see you guys in the next one.